Hello, there's a new day and new question on LeetCode. I'm solving these questions to prepare for future interviews as a software developer. So let's see what we have. Oh, sorry, what do we have today as a question? It's day number 21 and we have another hard. There's unfortunately not enough skill in me to solve hard questions, but let's try. Let's do our best. Zero indexed array of heights, positive integers, height of building. If a person is in a building I, they can move to any other building j if and only if I is less than j and height I is less than height j. You also given a queries array, and in the query, in each query we have Alice in building and Bob in building B. Answer I in the leftmost building where Alice and Bob can meet on the is query. Or -1 if there is no possible combination. So basically we have to find smallest index of a building where each of this, all two of these start points can meet. So we start from 0 and from 1 where we can meet. So we can move from 6 and from 4 to 8. And that's all. So it will be index number 2. So from 0 and from 3 it will be 7, right? From 2 and 4 we can't move anywhere because we don't have number greater than so basically we have to find any number greater than first and second element and to the right of second element. So we will it can be complicated. So probably we have to pre-calculate something. We can do naive implementation, so we can go from the second index and try to find element to the right of the second index, which is greater than first and second. We can simplify it by greater than max of these two indexes. Greater than greatest of these two. Yeah, let's do naive implementation, and probably there will be a place to improve, or maybe we can just solve this. Do I miss something? Okay, let's start with int array of answers, which is new int array of size queries length, get length, and we can, I think, arrays fill. Is there such method? Arrays fill. Right. Is there specific value? Array value. Okay. Yeah. So arrays fill ans -1. So this way we are recalculating values. So int I equals 0, I less than queries I plus plus int n equals max. So it hates, and here we have queries I 0, queries 1. So max of these two, right? And we have to find there's always is b always greater than a. I don't see this condition, so a can be greater than b. Okay, int for int j equals math max max of these indices. Plus one probably, right? Because we should start from also for the last one we are 1, 2, 3, 4, 5 in this query. Alice can directly move to both buildings. Yes, so we are starting from the same index. We can move if we also have to check if can move instantly to the second, and until j is less than, what is the j? J is the index until the j is less than query length, not query length, it's j++. We check if it's j is greater than 10, and I equals, what do we have? Yeah, equals j. And we have to break here. We are breaking, else we will go to the end and we will not change this variable. We will return once. So min index is this one. Yeah. This one. Min. So if it's min, right, it's less than its max, once I equals max. So for this pair, max index will be the answer, and continue. So else Let's try to run this. It's wrong answer. There's -1 and should be, what should be 2? For the last pair it's 2 and 2. All max equals me. Okay, let's solve this. Yes, and yes, and let's try to submit and see what is the performance. Yeah, I was hoping that it will not be the case, but it is the case. So we have to somehow pre-calculate this one. So for each j which is max index, we have to find such height which is greater than this index. Index of the height which is greater than max height in our pair. So we know the index we are at. It's max index. So we can replace it with min and max. So we can go to like element is greater than b. So we assume that b is right element in the pair. So we're trying to find if it's greater than b. We will check if this element is greater than a and b. If it is not, we will find the next element greater than this one, and if it is okay for each this is simple part. We touch this. We have to pre-calculate prep maxes calculators for each creators for each index in height. Heights greater heights I. For this it will be greaters I will be the index of next greater element. How can we do this efficiently? So for rightmost element, greatest will be this element. For the next one, it will be either previous element or this element. If the next one is greater than the previous one, so let's see in the description. So for this element, greatest will be this element itself. For this, greatest will be previous one. For this, greater will be previous, max greater than this one. But we can check if greater than this one is not great enough, and we will check once again next one greater than this one. If there is no greater than this one, we will set this one as the greatest. So for this one, we will check this one. For this one, max will be the 7. We'll check 7, 7 will be the max. So it's still not enough, and we will have 8 as a max. For 4, it will be max for previous one. Previous one, it will be the previous one. Yeah, greater than this one will be previous one. For this, greater than this one will be greater of previous one. It will be 8. Okay, let's try to prepare for int I equals 8 minus 1. Int great int g equals new int of its length, right, and g length minus 1 equals it's minus 1. So the last one will be itself. There is no greater element than this one. No, we have to have indices here. So for this one, it will be the index. So for each element starting from 1, so if heights j is less than heights j plus 1, we will set j equals j plus 1. Else, so if this element is less than next one, it will be, so next one will be greater than this one. Else if heights j is less than heights j plus 1, so if the next if So next int, next greatest is next greatest index is this one, so element right of the current one. And if while so greatest j equals j for now. Next greatest is j plus 1. So if it is while next greatest index, we will, while height is j. So we're starting from we are assuming this greatest index for j is j itself. So then we will try to find so if it is while true, while something, if it's j is less than its next greatest index, greatest j equals next greatest index, else next greatest index equals g next greatest index. So while next greatest index is less than one. And x equals -1. Max equals max j. While j less than and max I equals if max less than is j, max equals j, is j, max I equals j. So until nj is I, why it's j, where I've got this j, should be I, also I, also I, also I, and here also I, 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 sorry, so I, also I. So we calculated this. I think I've done some mistakes in the let's try to do system parent arrays to string array. Not sure if it will work, but so let's run. What is string? It's I and hates. And J I. Okay, max. of arms. So why it is so -2? Yeah, because it should be minus. Why? Why it not failed? As it should. Yes. But why you are not failing on those cases? Strange. It's still out. Yes, okay, let's see. So for this index 5 will be the max. 0, 1, 2, 3, 4, 5. For this also 5. For this max will be also 5, not 3. For this it will be 2. For this it will be 2. And for this it also should be 2. So yeah, if we stepped on some NGI, yes, let's try this. I'm now debugging this part only. Time index exceeded. I need this one. It's still not correct. For 3 it should be 7. For 3 it should be 5 too. So we are going through. For last one it will be the same. It will be index 5. We're starting from index 4 and we check if index 4 is, if hated index 4 is less than hated in next index. If it's so, for index 4 it will be index 5. Okay, and we'll go to index 3. Index 3 is not less than index 4. So we set here index itself, index 3, and next greatest index is 4. And while 4 not equals G4, and it is not, because here is 5. We check if height and index I is less than height and index 4, and it is not true. So next greatest index is greatest index at index 4, and it is index 5. We are checking if it is so if we are at the situation where we are stuck at if so if it is, and we are breaking the cycle, so we're checking if it is okay, and then we break, because there is no point to go for. Maybe it's not optimal, but it should work now. Time exceed. Equals. Yes, and we have 555. 4 to 8 is 2, 4, 4. Yes, 4, 4, 4. Okay, so we have this straightened out. And so let's return to this part. So we have max index, and we have to check. So while something, if greatest for our max index is greatest index is more than n, we will set answer I to this Gmax. Else max will be Gmax. If Gmax equals max, break. So basically the same while true. Let's try. Bad sign. Yeah, time limit exceeded. So we have max and max index, right? Must index, and we have max, which we can choose. But not so looking at this part. So we're checking if greatest at max index, we will check get next max element, index of next max element. We'll check if it greater than n. If so, we are found our answer, and it is this Gmax. Else we will set max at index of this Gmax. We will go to the next. And each time we will check if this element is greatest of, so there is no elements. We will check if, because there will be some element which is max. We will check again if it's greater. We will yes while time limit exceeds. And this value taken from heights, right? G is our calculated array. Yes. And time limit exceeded. So there is something. Okay, it's too long, it's taking too long, so I will revisit this later and see you next day.